Hello Raghav, good evening. All right, let's begin today's session. So let me start with my introduction. I'm Jeetendra Dixit. I did my BTech from IIT Kanpur and IIT-JEE aspirants for last 11 years. And today we'll continue continuity. Okay. So we discussed today first session. Yesterday was the first session of continuity, and today I'll discuss types of discontinuity and some other uh, important points related to continuity of various functions. And also, let me tell you about the subscription of Unacademy. So you can have two types of subscription: Unacademy plus subscription as well as Iconic subscription. So in plus subscription, you get access to daily live classes of all the educators, all right, who are teaching on the platform, and you also get access to all live test and quizzes. Uh, this is unlimited access. You can choose your educator according to your comfortability. Okay, there's no restriction. So all the educators who are taking live sessions or courses on Plus will be accessible to you. You can watch their live sessions. Okay, and these are the subscription charges. 12 months it is 38,500, and after 10% discount you'll have to pay 36,650. Similarly, for 24 months it is 56,000. Okay, you'll get 10% discount in this also. Use this code JEET1. An Iconic subscription is basically you get all the benefits of Plus. Other than that, you get a personal coach, an expert who will guide you throughout your preparation for IIT-JEE and all top exams of engineering. And your test analysis will be done in a personalized manner. Your study planner will be customized, okay, and reviews will be given to improve your time management and exam approach, all right? So this is what you get in Iconic subscription. And these are the charges for Iconic subscription: 56,000 for 1 year and 86,000 for 2 years. And of course, you'll get 10% discount. Use this code JEET1. So final price will be 50,400 for 1 year and 77,400 for 2 years. All right. This is Unacademy's learning app. You can download from Play Store. All right. And now let's begin the session. So we did types of discontinuity in yesterday's session. So there were two types of discontinuities: removable and irremovable, right? And in removable, there were discontinuities of again two types: isolated point and missing point discontinuity. And in irremovable, there were jump discontinuity, okay, in which left hand limit was not equal to right hand limit, jump discontinuity, as well as infinite type of discontinuity, and third was oscillating, right? So we did not do any example of that. So today first I'll give you some examples to finish. All right, so first example, let me give you fx is equal to, say it is fractional part of sine x. All right, fractional part of sine x. Fractional part of sine x. Fx is equal to fractional part of sine x. So check the continuity at x is equal to pi by 2. All right, and also if it is discontinuous, then find the type of discontinuity. Okay, that is the question. If it is discontinuous, if it is discontinuous, then find the type. If it is discontinuous, find its type. Which book are you using, Raghav? Yes, I will be teaching graphical transformation in the last week, all right? Last week of this month. All transformations, yes. All transformations I will be teaching. You follow any material, that doesn't matter. You just keep one book also. Okay, buy any book like Arihant or Singage, or just one particular material, okay, of any coaching. I mean, good, national level. I haven't seen that material of that particular you are talking about, but it must be good. So I'm taking transformation of graphs soon, next week. Okay, transformation of graph. Yeah, Arihant is good. You can do that book also. That will also be covered. Haven't you done functions? Transformation of graphs I'm doing next week, and then after that I'll cover the remaining part also. That is inverse function and composite functions. Oscillating type of discontinuity. Are you talking about, Raghav? Are you talking about oscillating type of discontinuity? Okay, I'll try to cover everything in detail. Okay, you are giving the answer of this. Fractional part of sin x. No. It is not oscillating type. See, when x, fractional part of sin x, if you know the graph, how to plot, by the way, see, when x approaches to 0, okay, limit when x approaches to 0, fractional part of sin x. Let's find the limit, not 0, sorry, pi by 2. We need to check at pi by 2, okay. So sin x is slightly less than 1, right? If you know the graph of sin x, it is 1 at pi by 2, and when it is approaching to pi by 2, when x is approaching to pi by 2, sin x is approaching to 1, but it is slightly less than 1, right? So if it is less than 1, then fractional part of sin x will be sin x only. So sin x is, you can write 1 minus delta. It is slightly less than 1 when x approaches to pi by 2. And because it is 1 minus, that means 1 minus delta. So here I should write delta approaching to 0, right? Delta approaching to 0. So 1 minus delta, if it is 1 minus delta, then fractional part of that will be 1 minus delta only, right? And then you can put delta is equal to 0, so it is 1. So limit of this function is 1, okay? Now let's check the value. If you find f of pi by 2, that is going to be fractional part of sine of pi by 2, right? And sine of pi by 2 is actually 1. So fractional part of 1, exact 1. And exact 1, then fractional part of any integer is 0. So fractional part is 0, all right? So this value at pi by 2 is 0, but limit left and right are same, 1. Okay, limit. So which type of discontinuity is this? Do you remember? Left hand limit is equal to right hand limit is equal to 1, but value of function is 0. Okay, so which type of discontinuity is this? Yes, I was talking about the graph of fractional. This is the graph of fractional part of sin x. Everything remains same in 0 to pi except this point. This point becomes 0. At pi by 2, value becomes 0. This is the graph of fractional part of sin x. So as you were talking about fractional, you were talking about this transformation of graphs. So I am going to cover that in next week, and in that you will learn all these things, all the transformations. So it is, yes, it is isolated. So it is isolated type. All right, good. Now let me give you another example. Cos of 2x minus 1 into pi by 2 when x is not, this is the function actually. It is well defined function. So fx is equal to this. You need to check at x is equal to 0. Only at 0 you need to check, okay? Which type, if there's any discontinuity or not. If there is any discontinuity, then find its type also, okay? Find its type. Getting anything? If you check RHN, then it is yes, it is continuous. Good. So it's 0 plus h, then it is going to be 0 plus h. Greatest integer of 0 plus h is exact 0, right? And cos of, if you put 0 plus h in this, it is going to be 2h minus 1 divided by 2 into pi. This is also approaching to 0, and this is exact 0, so it is going to be exact 0. If you find LHL, then LHL is 0 minus h approaching to 0. So now this time greatest integer will not be 0, but cos of minus 2h minus 1 divided by 2 into pi. This angle is approaching to pi by 2, right? So angle is approaching to pi by 2, so cos of pi by 2 will approach to 0. So this cos of pi by 2 will approach to 0. This is minus 1. So minus 1 into 0 is 0 only, right? And if you check value of the function f of 0, that is going to be 0 only, right? Exact 0. So this function is a continuous function. Good. Easy. Now you need to check which of the following functions has or have removable type discontinuity. Right. So first function is edx is equal to 1. Sorry. First function is fx is equal to 1 upon ln of mod of x. Second function is fx is equal to x square minus 1 upon x minus 1. Third function is fx is equal to 2 raised to 1 upon 1 minus x. All right. And fourth is fx is equal to under root of x plus 1 minus under root of 2x divided by x square minus x. Okay, so these are 4 functions. In these 4 functions you need to check which of the following functions will have removable type. Okay, removable type, that means missing point or isolated point. Okay. So first has infinite type, right? First ln of mod of x, we know that, like this. So in first it is approaching to plus, it is approaching to minus infinity, right? Left hand and right hand, both sides. So limit is minus infinity, but limit should be, so whenever limit is minus infinity left or right, so it is infinite type. Infinite type. First one. Second is second, if you find the limit, then left hand limit and right hand limit are going to be 2, right? You know that x minus 1 we can cancel, and it's a line which is not defined at x is equal to 1. So at 1 it is not defined, so it is removable type but not isolated, it is missing point. Missing point. At x is equal to 1 there is no value, so it is missing point. Got it? First is see, do you know the graph of ln x? This is the graph of ln x, right? So if you put mod on x, then graphs becomes an even, this function becomes an even function, and you need to take the image of graph which lies on the right side of y axis about y axis. Okay, तो ये पूरे ग्राफ का रिफ्लेक्शन आ जाएगा यहाँ पे. Okay, left side also. So this is the graph of ln of mod of x. So when x approaches to 0 from right side or left side, you can see limit is going to be minus infinity. Log of 0 plus is minus infinity. Now log of 0 minus will also be minus infinity. So both left and right limits are minus infinity. That means this function is infinite type of discontinuity in question number 1. In second, rationalize. Are you talking about fourth one or second one? No, in second one, you can factorize, not rationalize. Okay, x square minus 1 upon x minus 1. First of all, this function is not defined at x is equal to 1. You can see at 1, at x is equal to 1, it is 0 upon 0, which is not defined, right? Which is not defined. But that will become, now you can, what you can do, x square minus 1 upon x minus x square minus 1 can be written as x minus 1 into x plus 1. Okay, right, like this. And when x is not equal to 0, then you can cancel. Okay, but not at x is equal to 0. At x is equal to 0, this is not defined. Okay, you can't cancel 0. So when x is not equal to 1, sorry, not 0, when x is not equal to 1, then you can cancel these factors. So it is equal to x plus 1, but when x is not equal to 1. Okay, so it will be equal to x plus 1, but when x is, that's why I have plotted this line x plus 1. But you can see there's a hole. Okay, at which point? At x is equal to 1, because at x is equal to 1, this is not x plus 1, this is not defined. Okay, this expression is not defined at x is equal to 1. So left and right limit will be 2, but this point, at x is equal to 1, function is not defined, hence it has missing point discontinuity. All right, I hope it is clear. Oh, sorry, yeah, in first one. Okay, yes, I'm sorry. You're right. You're right. You are right. It is 1 upon infinity. I was just checking the I did not see 1 upon. I just focused on ln of mod of x. So it's not infinite type in first one. Sorry, a big mistake. So this was approaching to minus infinity. So 1 upon minus infinity is going to be 0. Okay. So fx when x approaches to 0 is approaching to 0. Okay. So left hand limit and right hand limit will be 0. And f of 0 is not defined. Okay. Is not defined. You can't put 0 in ln x, right? So 0 is not even in the domain of the function. So f of 0 is not defined. So again, missing point. This is also missing point. Left and right limit are same, equal. Thank you. Oh, shit. What am I doing? Okay, so here I was talking at x is equal to 0. Now, because we need to check at x is equal to 1, so again there's a twist. At x is equal to 1, story will be again different. So what would be the story? So 1 upon ln x when x is approaching to 1, okay? Then its right hand limit is going to be 1 upon ln of 1 plus h, and ln of 1 plus h is approaching to 0 from right hand side, okay? So it is 0 plus, and it will be plus infinity. And when x approaches to 1 from left hand side, that means left hand limit. So left hand limit is going to be 1 upon ln of 1 minus h, and ln of 1 minus h is 1 upon 0 minus slightly less than 0, and this will be minus infinity. So left hand limit, right hand limit is plus infinity, and left hand limit is minus infinity. So here I was talking about the continuity at x is equal to 0. So at x is equal to 0, it is missing point, yes. But at x is equal to 1, it is infinite type only, okay? So it is infinite type, okay? Non-removable. So this is not our question. That's why I'm removing this. Okay, have you checked third option and fourth? So let's discuss third one. So what are you getting in third? Which type of discontinuity is there? Obviously, it is not defined that x is equal to 1, so there must be some kind of... All these functions you can check. All these functions are not defined at x is equal to 1. That means all will have some kind of discontinuity, all right? Either it will be missing point or it will be irremovable, okay? No, it can't be continuous. No, none of the four will be continuous. Why? Because at x is equal to 1, none of the function is defined. 1 is not in the domain of any of these four. You can see denominator is becoming 0 in all four. This is not defined at x is equal to 1. This is not defined at x is equal to 1. This is not defined at x is equal to 1. So they have discontinuity. That is for sure, all right? That is for sure. Now question is, now which will have removable type? That means in which of the following left hand limit will be equal to right hand limit will be equal to finite, okay? So we have got that only in second so far. Now let's check third. So we need to check only left hand limit and right hand limit, okay? That's our prime focus. So left hand limit is 2 raised to 1 upon 1 minus h. H is approaching to 0. So it is going to be 2 raised to 1 upon h. H is approaching to 0. So it is 2 raised to, this is infinity. So 2 raised to infinity. Now 2 raised to infinity is also infinity. 2 raised to infinity. And 2 raised to infinity is also infinity. So again infinity, alright. So it is infinity. So anyways, we have got the answer. Answer is that it is irremovable type, infinite type, right? So it is irremovable, but still let's check right hand limit, okay? Because this is an interesting question. So what is right hand limit? Right hand limit is 2 raised to 1 upon 1 minus 1 plus h, okay? Okay, and after that you'll get 2 raised to 1 upon minus h in this case, okay? And minus h is minus infinity. So 2 raised to minus infinity. We did one such question yesterday also. 2 raised to minus infinity is 0, right? So 2 raised to 0 and 2 raised to 0 is 1. So right, that's why I was saying that this is interesting, all right? So right hand limit is 1. Although it won't change the result. Result is infinite type of discontinuity only. But this limit was interesting. The last one. So in last one, yes, in last one limit will exist, all right? So you just need to rationalize it. If you rationalize it, it will be x minus 1, x plus 1, sorry, minus 2x divided by, if you take x common, it is x minus 1. And you need to multiply and divide by x plus 1 plus under root of 2x. So it is going to be 1 minus x. This is nothing but 1 minus x, right? So 1 minus x will get cancelled with this, with minus sign will be there. So minus 1 upon x into under root of 1 plus x plus under root of 2x, all right? So when you put x is equal to 1, now you can put x is equal to 1. So you'll get both left and right, both limits, okay? So both limits will be minus 1 upon 1 into, this is root 2 plus root 2. So yes, in this case you are getting left hand limit is equal to right hand limit is equal to 1 upon minus 1 upon 2 root 2, okay? So yes, this one is, so second and fourth, okay? These are the options in which function is having removable type of discontinuity. Good. Now let's do one more question. So I'm giving you a function minus 1 raised to, it is greatest integer of x square when x is less than 0, and it is going to be 1 upon 1 plus x raised to n when n is approaching to infinity, limit when x is more than or equal to 0. Okay, I'll come back to this question, but let me discuss one more thing with you. Suppose this is a function fx is equal to x raised to n minus 1. 1 minute. Let me put mod of x raised to n divided by mod of x raised to n plus 1. N is approaching to infinity, okay? So check the continuity of this function. Check the continuity. First we'll do this problem, then we'll go to that one. Continuity for, check the continuity of f, and if there is any discontinuity, then find its type. So this is a very good question. Sometimes they put n power on the function of x, all right, and n approaches to infinity. So first you'll have to find that limit, and whatever the limit comes in terms of x, obviously it will come in terms of x, because you'll have to treat x as a constant. You'll have to define some intervals. So what, do you know the concept, how to use it? Okay, you try it, but I'll tell you the concept meanwhile. Whenever you have a raised to n, then it has only 3 values, okay? N is approaching to infinity. it will be infinity if a is more than 1, or you can say mod of a. Okay, let's discuss a only. A is more than 1. If a is equal to 1, then that will be 1 only. 1 raised to infinity is 1. And if a is less than 1 and more than 0, if it is between 0 and 1, then any number which is magnitude wise less than 1 to the power infinity will approaches to 0. So this is the concept which we need to use to find this fx first of all. Once we get the fx, then we will find the discontinuity. Try this one now. Let's see how long I continue with this. I'll tell you by the end of this month, okay? Answer of this question I'll tell you by the end of this month. Okay, so let's discuss then. Have you got any answer? This is a very interesting concept. At which point it is discontinuous? Okay, I'll try to answer it. First of all, you can see this is the term on which you have power n, right? So basically you need to find the limit of this. See, so whenever x mod of x is more than 1, so this term will approach to infinity, right? If mod of x is more than 1, because any number which is more than 1 magnitude wise to the power infinity approaches to infinity. So this means when x belongs to minus infinity to minus 1 union 1 to infinity. All right. So in this interval, this term is approaching to infinity. When mod of x is equal to 1, then this term will be exactly equal to 1. Okay. That means for x is equal to plus minus of 1, this mod of x raised to n will be plus 1 only. But when mod of x is less than 1, okay, less than 1 means when x belongs to minus 1 to 1. So in this interval, magnitude of x is less than 1, and that to the power infinity using this logic is approaching to 0. All right. So we'll have to define this function in 3 intervals. See, so when first let's solve in this interval, okay. So when x belongs to case 1, case 1. When x belongs to minus infinity to minus 1, union 1 to infinity. So in this interval, fx is, now this term is approaching to infinity. We know that this term is approaching to infinity. So it is infinity by infinity form. Because it is infinity by infinity form, so we need to take infinity common. We did that in the limits. So mod of x raised to n we will take common, and it is going to be 1 upon mod of x raised to n, right? That was the concept in infinity by infinity. Take largest term common. So mod of x raised to n common from denominator also. It is going to be 1 upon 1 plus mod of x raised to n, right? Now these two terms will get cancelled, and limit of this, n is approaching to infinity. So limit of this is going to be, this is 1 upon infinity will be 0, this is 0, and this is also 0. So 1 upon 1 is 1, okay? So we have got fx is equal to 1 when x belongs to this interval, okay? Similarly, case 2 is when x belongs to minus 1 to 1, okay? I'm taking this case, okay? Plus minus 1 we will do easily. So when x belongs to plus minus of 1, then it is very simple to answer, because this term is approaching to 0, this term is approaching to 0, and it is not indeterminate form, because it is written 0 minus 1 upon 0 plus 1. So it is minus 1 only. As simple as that. And case 3 is when x is equal to plus minus of 1. So when x is equal to plus minus of 1, in that case we know that mod of x raised to n is equal to 1 only. So if you put 1, then numerator is going to be 1 minus 1 divided by 1 plus 1. So it is going to be 0. Okay. So these are the values we are getting. If I plot them, then you can easily figure it out. See, this is 1 and this is minus 1. So you have 3 cases. In the first case, minus infinity to minus 1 and 1 to infinity, excluding the endpoints 1 and minus 1, limit was 1. So fx is equal to 1, constant function. Open and open. This is your fx, okay? This one, fx. Now in the second case, when x belongs to minus 1 to 1, fx is minus 1. So minus 1 to 1, fx is minus 1, all right? And when x is equal to plus minus of 1, then fx will be 0. So at these points, okay? Now tell me where this function has discontinuity and what kind of discontinuity it is. Answer fast. Now you have the graph. Yes. First we are observing whenever you have variable to the power n and n is approaching to infinity and that is equal to some function, that means you'll have to find the limit first of all, and whatever the limit comes, that will be the value of function. So you can see what kind of discontinuity this function is. This green color graph is graph of fx. Not isolated, beta, not isolated. In isolated, left hand limit is equal to right hand limit. Do you see left hand limit is equal to right hand limit? First of all, left hand limit should be equal to right hand limit for isolated or missing point, okay? So think about it again. Do the correction. Tell me the right answer. At 1, check 1. See, at x is equal to 1, I'm expecting answer from you, beta Raghav. Alright, then I'll answer. The right hand limit here is 1, right? Right hand limit is 1. Left hand limit is here. So left hand limit is equal to minus 1. So when left hand limit is not equal to right hand limit but both are finite, then that is called jump discontinuity. That is jump. jump discontinuity, and value of jump is left hand limit minus right hand limit mod, right? So it is going to be 2. This value, this length is called jump, right? So there is 2. It's not missing. Missing is when value of the function is not defined. Missing or isolated occur when the left hand limit is equal to right hand limit, but you can see there's a gap. Left hand limit is +1 and right hand limit is -1. Okay, so left and right limit are not equal, so it's a non-removable type of discontinuity, right? Okay, so before going to that particular example which I have written earlier, I'll give you another example. Okay, so you need to practice first of all this particular concept. Now you have sin x raised to n. I'm giving you easier example. Okay, now this time sin x raised to 2n. N is approaching to infinity. Okay, just let's discuss the continuity at for x belonging to 0 to 2 pi. Okay, only for this interval, and then we can generalize because it's a periodic function, so values will repeat. Okay, so let's discuss this function. Now you need to apply the same concept here also. So you know sin x is you can write this as sin square x whole raised to n. Okay, n is approaching to infinity. So if you know the graph of sin square, do you know the graph of sin square? It is like this only. Maximum value will be 1, but it will always be above x-axis. This is the graph. So you know sin square x is always less than or equal to 1 and greater than or equal to 0, right? It will be discontinuous. See, when sin square x belongs to 0 to 1, 1 excluded and 0 included, you know sin square will always be between 0 and 1. Okay, that is very simple, but I'm leaving 1. Okay, just leave 1 aside. So when sin square x belonging to 0 to 1 including 0 but excluding 1, then sin square x raised to n approaching to infinity will approach to 0. That means fx will be 0. Okay, so sin square is always less than or equal to always less than 1, except for few points. Where is this equal to 1? Where is this sin x is equal to 1? Sin x is equal to 1 for these points. This point is pi by 2. This point is 3 pi by 2. Okay, I'm talking about sin square. So when sin square x is equal to 1, that means x is equal to 2n plus 1 into pi by 2, odd multiples of pi by 2. Okay, then sin square is 1, and other than these values sin square is always less than 1. Okay, yeah, pi by 2, and if you generalize it, then this is odd multiple of pi by 2. Then sin square x raised to n will be actually 1, because 1 raised to infinity is 1 only, right? Exact 1 raised to infinity is 1 only. So that means in this case fx is equal to 1. So you have two cases. You have got the function. You have got your function fx is equal to 0 for all values of x except odd multiples of pi by 2. All right. Yeah. And 1 when x is equal to odd multiples of pi by 2. Getting this? So if you want to plot the graph of this function, then it will be very interesting. See, plot this x and y. Have you got it, Raghav? Are you getting this? So all these values which are less than 1, see these values I'm marking on the graph of sin x. All these values, when you put infinite power on these values, which are actually less than 1, these values will become 0, right? They will approach to 0. So this graph will become a straight line, horizontal. Leave this pi by 2. Leave this 3 pi by 2. So keep leaving these values, all right? And this minus pi by 2. So at these points, pi by 2, 3 pi by 2, sin x is exactly equal to 1. So that raised to infinity will remain 1. Okay. So that will be the graph of sin x raised to 2n. Are you getting this? Now can you answer? Now you are correct. This is isolated. Okay. This has isolated point of discontinuity at odd multiples of pi by 2. Okay. So fx has isolated point discontinuity at x belonging to odd multiples of pi by 2. All right. That is your answer. Left hand limit is equal to right hand limit is equal to 0, and point is separated. So that value is separated. That's why it is called isolated point of discontinuity. Okay. Now you got it. Now let's do this example. Okay. Now you are prepared for this example. I hope you can do it now. So that is your main point. Okay. We were discussing so many things to crack this particular function. And we want to discuss this discontinuity. Discuss okay, let's discuss for all x. No problem. For all x, okay, we are discussing the discontinuity for all x. First of all, we are going to crack this. Leave this as it is for x less than 0. Let's crack this one. Okay. So when x belongs to 0 to 1, including 0, excluding 1. Then x raised to n will be 0, right? This will be 0. Because any number which is less than 1, magnitude wise, I mean between 0 and 1, raised to infinity will approach to 0. So it is 1 upon 1 plus 0, so it is 1 only. Okay, so f x is 1. When x is equal to 1, then x raised to n will be 1. So it is 1 upon 1 plus 1, so 1 by 2. But when x is more than 1, then x raised to n will be approaching to infinity. When x is more than 1, when x is equal to 1, when x is less than 1, right? And more than equal to 0. Then x raised to n will be infinity, and 1 upon 1 plus infinity means 0. So we have got this function right side. So let me plot it here. Let's keep plotting as well. See, so if we need to find the discontinuity at some given point, then it will be very easy question. But because we need to figure out the discontinuities for all values of x, so we are discussing this function for all x. So we have already discussed it in the interval positive side of x-axis. That means positive values of x. So 0 to 1, it will be 1 only. Sorry, not this line. 0 to 1. So 0 to 1. 0 to 1, it will be 1. Okay. 1 is open. At 1, it is 1 by 2. At 1, it is 1 by 2. This point is 1 by 2. This is 1. This is 1. And after 1, it is 1. It is 0. So from this point, it is going to be 0 for all up to plus infinity. Okay. So yes, at x is equal to 1, it has jump. So this is jump discontinuity. Jump discontinuity at x is equal to 1. Okay. Now let's discuss for negative side. Okay. So that means we need to crack this function, greatest integer of x square. So this is certainly an integer, right? Because of greatest integer function. So minus 1 raised to integer will be either plus 1 or minus 1. So that depends. Whenever it is even integer, it will be plus 1, or odd integer, it is minus 1. Okay. So when is this function an integer? Okay. So if we check in 0 to minus 1, minus 1 to 0, it will be minus 1 only, right? So see what will be these points. Minus 1 to 0. X square is equal to 1. X square is equal to 2. You'll have to crack these points. X square is equal to 3. X square is equal to 4. So from this you'll get x is equal to plus minus 1. So we are interested in negative values. From this you'll get x is equal to minus root 2. From this you'll get x is equal to minus root 3. Okay. So minus 1 to 0, this value will be, this value minus 1 to 0, this will be minus 1 raised to 1. Because minus 1, this greatest integer of x square will become, 0. It will become 0. So it is going to be 1. So it is going to be 1. When x belongs to, I'm repeating. When x belongs to minus 1 to 0, then x square will be between 0 and 1. X square will become positive, right? So x square will be between 0 and 1. And greatest integer of x square will be 0, right? That's why minus 1 raised to 0 will be 1. And in the next interval, what is the next interval? Are we taking this value, minus 1? No, we are not taking this value. Then minus 1 to minus root 2. Okay, I'll write it here. When x belongs to minus 1 to 0. 0 is not included, by the way. Minus 1 to 0. Then x square belongs to 0 to 1. All right. And then minus 1 raised to, then greatest integer of x square will be 0. Okay. And then you can put the value. When x belongs to, now next interval you need to take minus root 2. Minus root 2 to minus 1. Now minus 1 will be included. minus root 2 will be excluded. So x square will be 1 to 2. X square is 1 to 2. So greatest integer of x square will be 1. And then minus 1 raised to 1 is minus minus 1. So this value will become minus 1. It will be either plus 1 or minus 1. Okay. It will keep changing. This is closed and this is open. So this is minus root 2. Then in next interval minus root 2 to minus root 3, it is going to be plus 1. Okay. So if you keep doing that, then minus root 3 to minus root 4, it will be minus 1. Then minus root 4 to minus root 5, it will be plus 1. So it will keep changing. Okay. What are the points where this is discontinuous? So we can generalize this point. My under root of n minus under root of n. X is equal to minus under root of n, where n is a natural number, right? Minus 1, minus root 2, minus root 3, minus root 4, minus root 5. So at these points, f function has jump discontinuities. Jump discontinuity, okay? And value of jump will be, jump is equal to 2 units. But at x is equal to 1, jump value is 1. Here jump value is 1. So it has jump discontinuities wherever it has discontinuity. But jump value is 1 at x is equal to 1. And for rest of the points which are actually under root of minus under root of n, yeah, that's an advanced level question. Yes, you must have seen that. All right, so today we'll end our session here. We'll continue tomorrow. Okay, I'll tell you some more concepts of continuity and differentiability. I'll do properly. All right, might be in previous year, I don't know, previous year. Okay, all right, Raghav, then we are ending today's session. Thank you very much for attending this. Like my videos. All right, if you're enjoying watching them. All right, take care. Good night. Yes, I'll tell you the first. Let's learn these things, and then I'll tell you the important points which will reduce your efforts. Okay, so those points are going to come in upcoming sessions. Yes, 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 of course. All right then. Take care. Good night.